All right, so in the previous videos, we saw some properties of limit, and the two functions are being multiplied, subtracted, added, and all that stuff. In today's video, we're going to see how to find the limit of composite functions. Now, we all know what are composite functions. Like there's a function inside of a function like here. Now, let's take two different functions. Let's say t of h of x. So we got a t, another function, and we're taking h of x as an input inside the function t. And then we're getting a complete output or number, let's say a. Now let's take an example. I have a function. Let's say y equals radical x squared minus 3. So this is the function y equals x radical x squared minus 3. Now we got two different functions right over here. So first of all, we have got this x squared minus 3 function. So first of all, we take x, we input that into this function x squared minus 3. Let's say this, so that's a function x squared minus 3. And what do we get? We get an output. Let's say we get an output a. And then we again put that output inside this radical function to get our answer as y. So you put x, you get y. But you're going through two different types of function inside, right? So now the outer function is that radical, and the inner function is that x squared minus 3. So it's a pretty simple thing we're going to see today, but now we're going to use limits in that. All right, so there are the two different conditions that need to be true in order for this limit to exist. So how do we calculate this? First of all, we take out this f function out. We take out this f function out, and we put that whole limit with this g of x function inside as limit as x approaches -1 of g of x. And that is the solution. That's pretty much all the solution for this whole question right over here. First of all, we calculate what's the limit as x approaches -1 of the inner function g of x, and then we take whole of that value and put that into the f function to get the definite answer. So let's plot some graphs over here and then calculate what this limit is going to be equal to. All right, so we got two different graphs. First is f of x, and then we got another graph of y equals g of x. Now we need to figure out what this limit is going to be equal to. So we saw the solution to this is going to be equal to the limit as x approaches -1 of f of g of x. And we just calculate out it using this f of limit as x approaches -1 of g of x. So first we take out the inner function and then take the limit and then input that answer into that f function to get the output. So in order for this whole thing to be true, the limit as x approaches g of x of g of x as x approaches -1 should exist. All right. So let's analyze. So what's the limit as x approaches -1 of g of x? Well, let's see. If we approach -1 from the right hand side, we seem to be approaching this number -1 in the y-axis. All right. And now if we approach from the left hand side, we see we are going to approach -1 again. So this limit is just equal to -1. Now, what is f of -1? F of -1 is going to be equal to, let's see, 4 right at this point. All right. So f of -1 is just 4. So we pretty much got our answer. This is the answer to this question right here. The limit as x approaches -1 of f of g of x. That's how we calculate out the limit of composite functions.